Welcome to the Dream Architect channel. Today, we will embark on a journey through the quiet, dusty corridors of cosmic memory, where forgotten wonders slumber on old magnetic tapes and faded photographic plates. We will sift through files left unattended, listen to signals that have long since fallen silent, and find poetry in lines of code and columns of telemetry. This is not a story of loud headlines, but a whisper of discoveries made on the periphery of attention, in the silence of laboratories, years after the spacecraft sent their final data to Earth. Somewhere out there, in the silent void beyond Pluto's orbit, two lonely wanderers began to slow their pace, as if a ghostly hand were pulling them back. This was the Pioneer anomaly, a mystery hidden for decades in columns of telemetry. The Pioneer 10 and Pioneer 11 probes, our first envoys into deep space, were deviating from their predicted trajectory by a tiny, yet measurable amount. Scientists went through all possible causes: the gravity of unknown planets, solar wind pressure, fuel leaks. Only years later, after a thorough analysis of old data, was the solution found in the spacecraft itself. Uneven thermal radiation emanating from its body created a microscopic but constant braking force. Thus, the greatest cosmic mystery turned out to be a quiet exhalation of heat, a reminder that even in the absolute cold of space, there are unseen currents. And where there is no heat, there is sound, born not in air but in plasma, and the Voyagers were the first to hear it. In the archives of their mission are the recordings of the plasma wave science experiment. This is not music in the conventional sense, but a sonification of data on the density of charged particles around the gas giants. When Voyager 1 crossed the shockwave at the edge of the heliosphere, its instruments recorded a sharp spike in plasma. Density. Converted into sound, this data sounds like a sudden, rising hum, similar to the roar of surf on a distant, unseen shore. This was the sound the spacecraft sent home for almost 10 years before it was heard and understood. The sound of our solar home colliding with interstellar space. This quiet roar of the void is still kept in digital archives, like an echo of farewell. This echo also has its visual twin, lost in the data from the same Voyager. We are talking about the family portrait of the solar system, the famous series of images, but something more than just the final mosaic is hidden in the archives. Stored there are hundreds of calibration, draft, and duplicate frames, in which the planets are just a few pixels of trembling light. In one of these forgotten images, Earth and Venus appeared in the same frame, separated by billions of kilometers of void. Two dim lights, two worlds, similar and infinitely different. This image was never widely published. It was considered a technical duplicate. But there is its own quiet poetry in it. The image of two sisters, frozen in an eternal dance around an invisible center, captured for a moment and forgotten for almost half a century. The dance of light and shadow continues in worlds closer to home, for example, on Mars. Long before rovers showed us its rocky deserts in high resolution, the Viking orbiters were mapping the planet in the 1970s. Strange, repeating patterns were found in their archives in the polar caps, which were initially written off as data transmission interference. These were dark spots that appeared in the spring. Only decades later, thanks to new data, did scientists realize that these were geysers of carbon dioxide. Sunlight, passing through a transparent layer of dry ice, heats the dark sand beneath it. The pressure builds, and the gas and sand erupt onto the surface, creating dark, fan-shaped patterns. The old, corrupted Viking images turned out to be the first, albeit misunderstood at the time, evidence of Mars's active geology. Geological activity is not always eruptions. Sometimes it is just quiet growth. Hidden in the data collected by the Magellan spacecraft, which mapped Venus in the early 90s, was a story of slow and relentless creation. Among the thousands of radar images of the planet's volcanic plains, structures were found called ticks, or arachnoids, radial fracture systems diverging from a central point. For a long time, they were considered just a type of volcano. But a detailed analysis of archival data showed that these were traces of magma rising from the mantle's depths, which did not break through to the surface, but only bulged and cracked the crust from within. These were the frozen imprints of the planet's breath, its slow, deep sighs, which Magellan had recorded without knowing it. A planet's breath can also be electric. When the Galileo spacecraft studied Jupiter, it recorded something strange in the behavior of its moon Io. Besides the obvious volcanoes, the data pointed to the existence of a giant electrical circuit between Io and Jupiter itself. This phenomenon, called the Io flux tube, is a stream of charged particles flowing along the magnetic field lines of the gas giant. Its power is trillions of watts, and it causes powerful auroras on Jupiter. Confirmation of this data was later found in the old Voyager archives, faint, barely noticeable fluctuations that were then dismissed as noise. It turned out that Voyager had detected this invisible river of energy 10 years before Galileo, but the discovery lay dormant, waiting for its time. Rivers of energy flow not only between planets, but also on them. On Titan, Saturn's moon, the Cassini spacecraft discovered not only methane lakes and rivers, but also something more mysterious, hidden in the radar data. These were magic islands, bright spots on the surface of the seas that appeared and disappeared in different images. For a long time, scientists could not understand their nature. Hypotheses ranged from waves to icebergs of frozen hydrocarbons. Analysis of older, less clear images showed that these phenomena were concentrated in specific areas. Most likely, these are bubbles of nitrogen rising from the bottom of the methane seas, similar to how bubbles rise in a glass of champagne. Titan turned out to be not just a cold world, but a living, effervescent landscape whose dynamics were first noticed as an inexplicable artifact. Artifacts and interference often turn out to be the key to discovery. In the 1970s, satellites designed to detect nuclear tests on Earth began to record strange bursts of gamma radiation emanating from random points in the sky. This data was classified and stored in military archives for decades. The military thought it was some new enemy technology. Only when astronomers gained access to these records did it become clear that this was not a terrestrial phenomenon. These were gamma-ray bursts, the most powerful explosions in the universe, marking the death of massive stars or the merger of neutron stars. Thus, an instrument created to monitor war accidentally revealed to us the most grandiose cataclysms of the cosmos, and this discovery was a state secret for a long time. It is not only deep space that holds secrets, but also our own moon. The Apollo program left behind not only flags and boot prints, but also seismometers. For several years, they recorded moonquakes. Analyzing this old data in the 2000s, scientists discovered a surprising pattern. Most deep moonquakes occurred when the moon was at its apogee and perigee, that is, at the points of its greatest and least distance from Earth. This meant that our planet's gravitational pull is still deforming the moon, causing internal stresses and faults. Old seismograms covered in dust in archives turned out to be evidence that the moon is not a dead rock, but a geologically living body that still breathes in time with the Earth. The Earth's breath, in turn, leaves traces visible from space. In the archives of early weather satellites from the 60s, images were found with unusual, perfectly round holes in the clouds. They were mistaken for defects in the film or optics. Only many years later, with the development of aviation and more precise observations, did it become clear that this was a man-made phenomenon. When an airplane flies through a layer of supercooled water droplets in a cloud, exhaust particles or vortices behind the wings trigger a chain reaction of crystallization. The droplets turn into ice crystals and fall down as snow, leaving a perfect hole behind. The old, mysterious defects in the photos turned out to be the first documented case of unintentional human influence on the weather. But sometimes the sky paints pictures without our help, And these pictures also long remained a mystery, hidden in the archives of amateur photographs. In the sky over the northern latitudes, a thin, shimmering ribbon of violet light sometimes appears, unlike the usual aurora. Amateurs named it Steve. Scientists, having studied satellite data archives collated with these amateur photos, realized that it was not an aurora. Steve is a stream of incandescent gas rushing through the ionosphere at a speed of 6 kilometers per second. It is invisible to most instruments, but becomes visible due to its heat. Thus, an ordinary person looking at the sky helped discover a new atmospheric phenomenon, traces, of which lay dormant in scientific archives. From this warm glow in the upper layers of the atmosphere, we can move on to other, even more spectral lights. Above thunderclouds, in the darkness where tranquility seems to reign, giant blue fountains of light sometimes erupt. These are blue jets, shooting up from the tops of clouds toward the edge of space. They were accidentally filmed from a space shuttle and were long considered a rare anomaly. But an analysis of archival video recordings from the International Space Station showed that this phenomenon is much more common. These silent discharges, resembling underwater eruptions, carry a charge to the ionosphere, playing their own, not yet fully understood role in the planet's global electrical circuit, like quiet, blue sighs of a thunderstorm. The influence can be more subtle, almost musical. In the data from the IMAGE satellite, launched in 2000 to study the magnetosphere, a phenomenon was discovered that was named choral hum. These are electromagnetic waves in the plasma that, when converted into sound, resemble the singing of a choir of birds at dawn. These songs arise when particles of the solar wind interact with the Earth's magnetic field. But the most interesting thing was found later, during the analysis of archival data. It turned out that the intensity and frequency of this chorus change depending on solar activity. The Earth literally sings in response to the sun's touches, and we have learned to hear this quiet music of space only by analyzing old recordings. The music of space sometimes sounds in stone as well. When scientists analyzed data from the Spirit rover, they discovered areas of soil in the Gusev crater with an abnormally high content of pure silica. This was a mystery until one of the researchers recalled his fieldwork in Yellowstone. There, identical deposits form around hot springs where acidic water dissolves rocks. Returning to the Spirit's archival data, the team found other confirmations, traces of water vapor, sulfates. It turned out that the place where the rover spent years was once a Martian Yellowstone, bubbling, full of geysers and fumaroles. The discovery was made not in space, but in the terrestrial archive of human memory and experience. Memory is stored not only by people but also by machines. In the data from the Cassini probe, evidence was found for the existence of another, almost invisible ring around Saturn. It coincides with the orbit of the moon Phoebe and consists of dust particles knocked from its surface by micrometeorites. But the most striking thing is its tilt and direction of rotation. The particles in this ring move in the opposite direction compared to all other rings and moons. This means that Phoebe is not a native moon of Saturn, but a captured object from the Kuiper belt. Old, barely noticeable fluctuations in the dust data turned out to be the key to unlocking the origin of an entire family of moons, telling the story of an ancient cosmic capture. Capture can also be gravitational. In the archives of observations of Neptune, made by Voyager 2, strange arcs and clumps were noticed in its rings. Unlike Saturn's rings, which are almost uniform, Neptune's rings seemed unfinished. For a long time, this was explained by complex dynamics. But a recent analysis of old data showed that these arcs are held in place by the gravitational influence of the small moon Galatea. It acts as a shepherd, preventing the ring particles from distributing themselves evenly. Thus, Neptune's defective rings turned out not to be a mistake of nature, but an elegant example of gravitational equilibrium, which was recorded but not understood decades ago. Equilibrium sometimes conceals chaos beneath it. The Ulysses spacecraft, launched in the 90s to study the sun from high latitudes, transmitted data about the solar wind. Within this data, during periods of low solar activity, strange, short-lived, and very fast streams of particles were discovered, moving against the general flow. They were named jets. At first, they were considered instrumental errors, but analysis of the archives showed that they are real and originate in coronal holes, regions with an open magnetic field. It's as if on a calm river, short, fast currents suddenly appeared, moving upstream. These errors in the data turned out to be the key to understanding exactly how the sun loses its mass, even during its quietest periods. The silence of space is deceptive, and even emptiness has its own structure. In the data from the IRAS infrared telescope, which operated in the 80s, thin, fibrous structures were discovered permeating the entire sky. They glowed in the far infrared range and were named infrared cirrus, or galactic cirrus clouds. Initially, they were considered artifacts in the detectors, but it turned out that these were clouds of coal dust in our own galaxy, illuminated by the combined light of the Milky Way's stars. They are invisible to conventional telescopes, but IRAS saw them first. This archival data revealed to us the invisible, dusty skeleton of our galaxy, showing that even the emptiest regions of the sky are in fact full of matter. This matter can be quite exotic. When astronomers studied archival data from the Chandra X-ray Observatory, observing the Perseus galaxy cluster, they noticed a strange emission line in the spectrum. It did not correspond to any known chemical element. This mysterious line at an energy level of 3.5 keV was also found in data from other telescopes and in observations of other galaxy clusters. One of the most intriguing hypotheses suggests that this could be a trace of decaying dark matter particles, such as sterile neutrinos. Thus, hidden in the noise of old X-ray spectra may be the first direct, albeit indirect, evidence of the nature of the most mysterious substance in the universe. Sometimes the mystery lies not in the signal, but in its absence. In 1967, graduate student Jocelyn Bell, while analyzing data from a radio telescope, discovered perfectly regular pulses arriving every 1.33 seconds. The first thought was that it was a signal from an extraterrestrial civilization, and the object was even given the jocular name LGM-1, Little Green Men 1. This data was met with enormous skepticism. But soon, other similar objects were found. It turned out that these were pulsars, rapidly rotating neutron stars, the remnants of supernovae. The discovery, which could have changed the world, turned out to be merely a new class of stellar objects, and its history, full of doubt and initial disbelief, is preserved in the laboratory logs and archives of Cambridge. Archives store not only discoveries, but also missed opportunities. In the 1990s, while analyzing old photographic plates from the Palomar Observatory from the 1950s, astronomers were searching for traces of moving objects in the Kuiper Belt. On one of the plates, they found a faint object that had shifted in the sky overnight. It was considered another asteroid and was not given any significance. Only decades later, when the large trans-Neptunian object Quasar was discovered, did scientists return to that old plate. It turned out that the very same unnamed asteroid was in fact Quasar. Humanity had photographed a new world half a century before its official discovery, but this knowledge lay dormant in an archive, waiting until we were ready to understand it. Understanding comes with new tools applied to old data. In the 1980s, the Pioneer Venus orbiter measured the concentration of sulfur dioxide in the atmosphere of Venus. The data showed a sharp spike, followed by a slow decline over several years. At the time, this was attributed to the peculiarities of the spacecraft's own operation. But in the 2000s, when the European probe Venus Express discovered fresh lava flows on the surface, scientists returned to the Pioneer archives. It turned out that the old spike in sulfur dioxide was most likely the result of a powerful volcanic eruption. Thus, data that had been considered erroneous became the first evidence of active volcanism on Venus, seen 20 years before its confirmation. Volcanoes can erupt not only lava, but also ice. When Voyager 2 flew past Triton, a moon of Neptune, it took images of its surface. Dark plumes, stretching for tens of kilometers, were visible in them. In real time, this was difficult to interpret. Analysis of these images, stored in archives, showed that they were traces of cryovolcanoes. Sunlight heats dark material beneath the transparent nitrogen ice, creating pressure that ejects ice and dust to an altitude of up to 8 kilometers. There, the thin atmosphere catches this material and spreads it, like smoke from a chimney. Voyager caught these eruptions in action, and their frozen traces are still visible in the old photographs, like ghostly shadows on the icy surface. Shadows can tell a story. In the data from the Mars rover Opportunity, microscopic spherical formations, nicknamed blueberries, were found. They were scattered across the surface in the Meridiani Planum region. Their perfect shape was a mystery for a long time. But a thorough analysis of their distribution and chemical composition, including comparison with old data from orbiters, showed that they are hematite concretions. On Earth, such formations form exclusively in the presence of water. These small stone spheres, found in the dust, became one of the most convincing pieces of evidence that liquid water existed on Mars in the past. The discovery was hidden not in grand canyons, but in microscopic details, awaiting their moment in the data archives. Details are sometimes hidden in the light itself. In the archives of spectra obtained with the Hubble Space Telescope, astronomers discovered something strange in the light passing through the atmosphere of the exoplanet HD 209458b, a hot Jupiter. Besides the expected sodium and hydrogen, there were traces of carbon and oxygen escaping from the planet's atmosphere. It was similar to a comet leaving a tail behind it. The planet was literally evaporating under the radiation of its star. This discovery, made during a reanalysis of old spectra, showed that planets can not only form, but also die, slowly dissolving into space, and we saw this process in action for the first time. The process of dissolution can be even more large-scale. In the data from the Sloan Digital Sky Survey, SDSS, astronomers discovered a giant stellar stream wrapping around the Milky Way. This was not a random group of stars. Analysis of their motion and chemical composition showed that these were the remnants of the Sagittarius dwarf galaxy, which our galaxy is currently tearing apart and absorbing. This data, collected to map the sky, had accidentally documented an act of galactic cannibalism in real time. In the archival sky maps, we saw the ghostly remains of another galaxy becoming part of our own. Stars also become part of something larger. In old data from the Rosat X-ray satellite, which operated in the 90s, faint, isolated X-ray sources were found, not associated with any visible objects. They were named the Magnificent Seven. For a long time, their nature was unclear, but subsequent analysis with more powerful telescopes showed that they are young, cooling neutron stars located relatively close to us. They are not pulsars and have no companions. They are simply hot, lonely supernova remnants, silently drifting through space. Their discovery was hidden in the archival X-ray noise, like 7 quiet ghosts. The ghosts of the past sometimes turn out to be quite tangible. In 2004, astronomers studying archival Hubble images taken in 1998 noticed a faint point of light near the star Fomalhaut. In images from 2006, this point had moved. This was the first direct image of an exoplanet in history, Fomalhaut b. But most interestingly, when scientists looked at even older archives, data from the IRAS infrared telescope from 1983, they discovered that there was an excess of infrared radiation around Fomalhaut. This was the dust disk in which the planet was born. Thus, we first saw the planet's cradle without realizing it, and only 25 years later did we spot the infant within it. Entire galaxies can also be infants. In the famous Hubble Deep Field image, where every point of light is a galaxy, there are numerous objects that were simply catalogued and forgotten. Years later, astronomers, using new analysis methods, returned to this archival data. They focused on the reddest and faintest objects. It turned out that these were the most distant galaxies ever detected, whose light had traveled for over 13 billion years to reach us. We see them as they were in the infancy of the universe. These ghost galaxies, barely distinguishable from the noise on the telescope's detector, turned out to be windows into the earliest epoch of the cosmos's existence, and they had been waiting for us all this time in a publicly accessible archive. Windows into the past are also opened by the cosmic microwave background radiation, the light left over from the Big Bang. In the data from the WMAP satellite, which mapped this radiation, a giant cold spot was discovered, a region with an anomalously low temperature. At first, it was considered a statistical anomaly, but a subsequent analysis of archival data from other sky surveys showed that in this direction lies a huge void, a supervoid, almost devoid of galaxies. Its diameter is over 1 billion light-years. The light from the cosmic microwave background passing through this void loses energy, which is what makes it colder. Thus, a defect on the map of the early universe turned out to be the shadow of one of the largest structures in the modern cosmos. Structures can also be magnetic. When the Cassini spacecraft flew through the tail of Saturn's magnetosphere, its instruments recorded strange, periodic pops and ruptures in the magnetic field. This data lay in archives for a long time, as it did not fit into the models. Only after comparison with terrestrial observations did it become clear that this is an analog of terrestrial substorms, a phenomenon called magnetic reconnection. Wow. The planet's magnetic field is stretched by the solar wind like a rubber band and then abruptly collapses, releasing a huge amount of energy. The archival data from Cassini showed that this process, which generates auroras on Earth, is universal for planets with a magnetosphere. The composition of the building blocks of life can also be universal. In the data collected by the Stardust mission, which brought samples of cometary material to Earth, glycine, the simplest amino acid, was discovered after many years of laboratory analysis. This was the first direct proof that key components for the origin of life exist in comets. But the most interesting discovery was made in archival radio astronomy data. It turned out that spectral lines corresponding to glycine had already been observed in gas clouds in the center of our galaxy, but they could not be confidently identified. The discovery, made in a terrestrial laboratory, allowed for a fresh look at old radio data and the realization that the building blocks of life are scattered throughout the Milky Way. Building blocks can also be more prosaic, but no less important. In old data from the Mars Reconnaissance Orbiter, dark streaks were found appearing on crater slopes during the warm season and disappearing in winter. They were named recurring slope lineae. For a long time, their nature was a subject of debate, but a spectral analysis, conducted based on the same archival data, showed the presence of hydrated salts, perchlorates. These salts can lower the freezing point of water to -70 degrees Celsius. This became the strongest indirect evidence for the existence of seasonal flows of liquid, very salty water on modern Mars. The key to water on Mars lay in barely perceptible changes in color on old images. Color changes can also tell us about the weather on other planets. Archival images of Jupiter, taken by Hubble over many years, have shown that its famous Great Red Spot, a giant hurricane the size of Earth, is steadily shrinking. Over the last 100 years, it has shrunk to almost half its size. Moreover, it is changing its color, becoming more orange than red. By comparing modern data with old sketches by 19th century astronomers, scientists have been able to trace this evolution. The greatest storm in the solar system is slowly dying, and the chronicle of its fading is recorded in observational archives, from glass photographic plates to Hubble's digital files. Fading is the fate not only of storms, but of entire worlds. Pluto, long considered just an icy ball, presented a surprise when the New Horizons spacecraft transmitted its images. But even before that, the Hubble archives held data that hinted at its complexity. These were albedo maps of the surface's reflectivity, compiled from barely perceptible changes in Pluto's brightness as it rotated. On these blurry maps, made decades before the flyby, a giant bright heart, Sputnik Planitia, could already be discerned. We saw a faint impression of Pluto's main relief feature long before we could see it up close, as if looking at the world through frosted glass. Glass is also sometimes found in space. In the lunar soil samples brought back by the Apollo 14 mission, tiny glass spherules were discovered. Their analysis, conducted decades later, showed that their chemical composition was completely unlike that of the Moon. It is much closer to terrestrial rocks. Moreover, the age of these spherules is about 4 billion years. Most likely, they are particles of Earth's crust, ejected into space by the impact of a giant asteroid, which then fell onto the Moon. In a container of lunar dust, stored for decades in an archive in Houston, we found a piece of the most ancient Earth, better preserved than anything on our own ever-changing planet. Changes on Earth are sometimes visible only from space, and even then, only in hindsight. In 1978, the experimental satellite CSAT operated for only 106 days, but managed to collect a vast array of radar data on the ocean's surface. This data was so complex that its full processing took years. When scientists were finally able to decipher it, they saw something astonishing. On the radar maps of the ocean, the outlines of underwater mountains, ridges, and trenches emerged. The gravity of these underwater structures creates barely perceptible changes in sea level, dips and hills on its surface, which the radar detected. The data archive, once considered almost useless, turned out to be the first relief map of the global ocean floor. Relief can also be temporary. In the archives of the Cassini mission, images of Saturn's North Pole were found showing a giant, perfectly regular hexagon of clouds, the hexagon. Each of its sides is longer than the diameter of the Earth. It was first spotted by the Voyager spacecraft in the 80s, but at the time it was considered a random formation. Cassini, however, observed it for years. It turned out to be a stable structure, a standing wave in the planet's atmosphere. Its nature is still not fully understood, but its existence, confirmed by comparing archival data 30 years apart, proves that astonishingly long-lived and geometrically regular weather systems can exist in the atmospheres of giant planets. The geometry of space also manifests itself in the distribution of matter. In the data collected by the Hipparcos satellite to measure distances to stars, a byproduct was discovered: information about the interstellar absorption of light. When this data was mapped, a structure emerged, named the bubble of the local interstellar cloud. It turned out that our solar system is moving through a region of low gas density, a sort of clearing in the forest of interstellar matter. This bubble was blown out by supernova explosions millions of years ago. We learned about our immediate cosmic surroundings not through targeted searches, but by analyzing the noise in astrometric data collected for a completely different purpose. Noise can also be a radio signal. The famous WOW signal, detected in 1977, is a powerful narrowband radio signal that lasted for 72 seconds and has never been repeated. It perfectly matched the expected characteristics of a signal from an extraterrestrial intelligence. But in the archives of radio observatories, there are other lesser-known candidates. For example, the signal SHG-B02+14A, discovered as part of the SETI at Home project while analyzing data from the Arecibo Observatory. It was recorded 3 times from the same point in the sky, had a very stable frequency that, moreover, drifted as if the source were on a rotating planet. There is still no explanation for it, and it remains one of the many mysteries lying quietly in the project's giant digital archives. Mysteries are hidden not only in signals, but also in their absence. Tabby's star, or KIC 8462852, became famous for its strange, non-periodic dips in brightness detected by the Kepler telescope. But when astronomers turned to the archival photographic plates from the Harvard Observatory, spanning more than 100 years, they discovered that the star, in addition to these rapid dips, has also been slowly dimming over the entire century. This does not fit any of the models. Neither a swarm of comets nor a dust disk can explain such a long-term and monotonous decrease in brightness. The old glass plates, Preserving light from a century ago only deepened the mystery of this star, turning it from a curiosity into a fundamental puzzle. Fundamental discoveries are sometimes made by accident. In 1995, while studying archival Hubble data of a globular cluster, astronomers noticed several faint reddish dots in the background. Spectral analysis showed that these were not stars, but something much colder. These were the first confirmed brown dwarfs, failed stars, objects too massive to be planets, but not massive enough to ignite thermonuclear reactions in their cores. They had been theoretically predicted for decades, but finding them had been unsuccessful. And all this time they were hiding in the background of archival images, like dim embers in the glow of real stars. Embers can also be diamonds. An amazing hypothesis was hidden in old data about the internal structure of Uranus and Neptune, obtained from their gravitational influence on Voyager 2. The immense pressure and temperature in the mantles of these planets should cause methane to break down into hydrogen and carbon, and the carbon to be compressed into diamonds. These diamonds, being heavier than the surrounding matter, must literally fall as rain, slowly sinking towards the planet's core. Thus, in the depths of the ice giants, eternal diamond showers may be occurring. This incredible picture was not drawn from direct observations, but through careful modeling based on sparse gravimetric data from a 30-year-old archive. Rain can also be iron. On the exoplanet WASP-76b, an ultra-hot Jupiter, one side always faces its star, while the other is plunged into eternal night. Observations, based on the analysis of archival spectra from Hubble and other telescopes, revealed something astonishing. On the day side, heated to 2400 degrees Celsius, iron vapor is present in the atmosphere. And at the boundary between day and night, where the temperature drops, the spectral lines of iron disappear. The only explanation is that on the night side of the planet, the iron condenses and falls as rain. We found a world where metallic showers fall at night, and this discovery was pieced together from various disparate archival observations. Grains can tell a great deal. In 2014, while analyzing old data from the Spitzer Infrared Telescope, astronomers discovered the coldest known brown dwarf. Its surface temperature is like that of Earth's North Pole, around -40–50 degrees Celsius. It is so dim that it could only be found thanks to its own motion against the background of stationary stars in images taken several years apart. This object, WISE 08550714, is only 7 light-years away from us. It is one of our closest neighbors. And this icy failed world hid for decades in the noise of infrared maps until its own slow movement gave it away. Motion can also be deceptive. Superluminal jets are streams of plasma erupting from the centers of active galaxies at speeds close to the speed of light. In images taken several years apart, it is visible that blobs in these jets are moving faster than the speed of light. This is, of course, an optical illusion related to the fact that the jet is pointed almost directly at us. But the most interesting thing was found in the archives of the very first radio interferometry observations from the 70s. These structures were already visible there, but the resolution was too low to understand what was happening. What was then considered just an elongated radio source turned out to be the first, not yet understood image of this relativistic marvel. Wonders sometimes hide in the most obvious places. The archives of the Apollo program hold thousands of photographs of the lunar surface. On many of them, a strange effect is visible. A horizontal glow above the horizon before sunrise or after sunset. Astronauts described it as twilight rays. For a long time, it was thought to be just lens flare or the glow of the spacecraft's residual atmosphere. But a recent analysis which compared these photographs with data from the Lady spacecraft showed that it is a real phenomenon. Lunar dust, charged by solar ultraviolet radiation, levitates above the surface, creating a rarefied, temporary atmosphere of dust particles. The ghostly glow that the astronauts saw was real, and evidence of it had been gathering dust in photo archives for half a century. Dust can not only glow, but also conceal. At the center of our galaxy lies a supermassive black hole, Sagittarius A. But around it, as archival infrared observation data have shown, orbit many young, massive stars. This is a paradox. The black hole's powerful gravity should have prevented their formation. The solution was found by analyzing old data on the motion of these stars. It turned out that they orbit not chaotically, but in two coherent disks. This means they were not born there, but were brought to the center as part of a gas cloud or a globular cluster, which was then torn apart by the black hole. The story of these stars' birth was recorded in their dance, and this dance was recorded in archives for decades. The dance of planets also holds secrets. Analyzing transit data collected by Kepler, scientists discovered systems where planets are in orbital resonance. Their orbital periods are in simple integer ratios. But the most interesting part was found in the archives of radial velocity data collected from Earth long before Kepler. In them, hints of the existence of the same planets were found, but the signal was too weak to be considered a discovery. Kepler's data made it possible to return to these old, noisy spectra and, knowing what to look for, extract confirmation from them. Kepler's discoveries were dormant in Earth-based archives for 10 or even 20 years before its launch. The launch of new ideas is sometimes triggered by old mistakes. In 1965, Arno Penzias and Robert Wilson, while calibrating a horn antenna, detected a constant, unexplained noise coming from all directions. They cleaned the antenna, got rid of pigeon droppings, and rechecked all the systems, but the noise did not disappear. They were ready to write it off as an equipment defect. But in the archives of theoretical papers at Princeton University, at that very time, lay an article predicting the existence of the cosmic microwave background, the cooled echo of the Big Bang, which was expected to manifest as precisely such, an all-pervading microwave noise. By connecting the accidental discovery with the forgotten theory, astronomers made one of the greatest discoveries of the 20th century. Theories sometimes wait decades for their confirmation. Gravitational waves, predicted by Einstein in 1916, were only first directly detected in 2015. But after this discovery, scientists developed new algorithms and applied them to archival data from the LIGO interferometer from previous years. And in this noise, previously considered useless, they found traces of other weaker mergers of black holes and neutron stars. It turned out that the universe had been speaking to us in the language of gravitational waves before, we just didn't know how to listen. The first chords of this cosmic symphony were recorded and saved long before we learned to recognize them. The Symphony of Earth's sounds was also recorded by chance. In the data from the CHAMP satellite, designed to measure Earth's gravitational and magnetic fields, strange low-frequency oscillations were discovered. Analysis showed that their source was not space, but the planet itself. These were infrasound waves from major earthquakes which, propagating upward, caused oscillations in the ionosphere that the satellite recorded. The data archive, collected for geology, unexpectedly became a tool for seismology, showing that the echoes of the Earth's crust tremors reach the uppermost layers of the atmosphere, leaving ripples at the boundary with space. Ripples on water led to another discovery. Analyzing archival radar images of Titan taken by Cassini, scientists noticed how the reflected signal from Ligeia Mare changed over time. It turned out that the bottom of this methane sea is perfectly smooth, like a mirror, but it is not solid. Modeling showed that it is most likely covered by a thick layer of organic sediment, similar to silt or tar, which has settled from Titan's atmosphere over billions of years. At the bottom of an alien sea, we found not rocks, but a soft, viscous layer of organics. And this discovery was made by analyzing the reflection of radio waves from its surface, recorded many years ago. A surface can tell a story not only about what is beneath it, but also about what is above it. In the archives of images of Mars taken by the Mars Global Surveyor, images of strange, spider-like channel systems were found near the South Pole. They were named areneiforms. They do not resemble any known erosional structure. Only after the discovery of carbon dioxide geysers, which we have already mentioned, did it become clear that these are their root systems. Gas, rushing towards a crack in the ice, carves these channels in the soil beneath it before erupting to the surface. The old, mysterious images of spiders turned out to be the missing piece of the puzzle explaining another, no less mysterious phenomenon. The origin of Jupiter's rings was also a puzzle. They were discovered by Voyager 1, but their structure and composition remained unclear. Only the Galileo spacecraft was able to study them in detail. An analysis of archival data on dust distribution showed that the main ring consists of material ejected from the surfaces of the inner moons, Metis and Adrastea, and the two wider and fainter Gossamer rings are fed by dust from Amalthea and Thebe. Jupiter's rings turned out to be not a static structure, but a dynamic system, constantly replenished by the bombardment of its own moons. The story of their origin was written in the distribution of dust particles, which Galileo meticulously recorded in its onboard archive. An archive can also be icy. In the data from the Mars Express mission, it was discovered that beneath the southern polar ice cap of Mars, there is a region that reflects radar signals very brightly. This corresponds exactly to how subglacial lakes appear on Earth. After multiple checks and analysis of data collected over several years, scientists concluded that this is most likely a lake of liquid, very salty water, buried under a 1.5-kilometer thick layer of ice. This is the first evidence of a large body of water on modern-day Mars, and it was found not by a camera, but by a radar that listened into the planet's interior and recorded its echoes. An echo can also come from deep space. Fast radio bursts, FRBs, are millisecond-long pulses of immense power coming from distant galaxies. Their nature is unknown. But after the discovery of the first repeating FRB, scientists returned to the archival data of radio telescopes aimed at the same region of the sky, and they found earlier, weaker bursts from the same source, which had previously been dismissed as interference. It turned out that the source had been active before, but its signals were drowned in noise. The archival data made it possible to trace the activity history of this mysterious object, showing that it has been flickering for a long time. The flickering of stars in the Kepler archives concealed another surprise. Besides searching for planets, the telescope also recorded the internal oscillations of the stars themselves, their starquakes. Analysis of this data for thousands of red giants allowed asteroseismologists to make a stunning discovery. They were able to distinguish between stars that are burning hydrogen in a shell around a helium core and those that have already ignited helium in their core. These two evolutionary stages are almost indistinguishable externally, but their internal structure is different, and this is reflected in the spectrum of their oscillations. The Kepler archive, created to search for worlds, gave us a tool to peer into the very hearts of dying stars. The heart of our own galaxy, it turns out, also beats. Analyzing archival data from the Fermi Gamma Ray Space Telescope, astronomers discovered two giant bubbles emanating from the center of the Milky Way, perpendicular to its plane. They extend 25,000 light-years in each direction and glow in the gamma-ray and X-ray ranges. These are traces of a giant energy release that occurred due to the activity of the supermassive black hole or a burst of star formation in the galactic center millions of years ago. These ghostly structures, invisible in the optical range, were only discovered when compiling a complete map of the gamma-ray sky based on many years of archival data. Maps can also be four-dimensional. In the data from the European satellite Gaia, which measures the position and motion of 1 billion stars with unprecedented precision, scientists discovered traces of ancient galactic mergers. By analyzing the velocities and trajectories of stars, they were able to identify groups that move differently from the main mass of stars in the disk. One such group, named Gaia Enceladus, turned out to be the remnants of a fairly large galaxy that the Milky Way devoured about 10 billion years ago. The Gaia Data Archive allowed us not just to create a map, but to conduct galactic archaeology, unearthing the bones of ancient worlds in the motions of modern-day stars. The motion of stars within globular clusters also turned out to be not so simple. For a long time, it was believed that all stars in a cluster are born simultaneously from a single cloud and should have the same chemical composition. But a detailed analysis of archival spectra obtained by Hubble showed that this is not the case. In each cluster, there are at least 2 generations of stars, differing in their content of light elements. This means that after the first burst of star formation, the most massive stars quickly exploded, enriching the remaining gas, from which a second generation was then born. The secret of the double life of globular clusters was hidden in the subtle differences of spectral lines in old images. Differences can also be found in shape. The Dawn spacecraft, which studied the asteroid Vesta, transmitted data that allowed for the construction of its precise 3D model. But when scientists compared Vesta's spectra with archival spectra of meteorites found on Earth, they discovered an almost complete match with a class of meteorites called Head meteorites. Moreover, a giant impact crater was discovered at Vesta's south pole. It turned out that Vesta is the only asteroid known to us from which we have samples. Billions of years ago, an impact knocked pieces of rock from its surface, which, after wandering through the solar system, fell to Earth. The stones, which had lain in museum archives for decades, found their distant homeland. Cosmic rays can also have a homeland. These are ultra-high-energy particles arriving from space. Their source was long a mystery. But in 2017, a high-energy neutrino was detected, and at the same time, gamma-ray telescopes saw a flare in a distant galaxy in the Blazer TXS 0506056. Scientists rushed to the archives and found data that in 2014-2015, an entire stream of neutrinos had already come from the same point, which at the time was not associated with any object. By comparing these events, astronomers were able to confidently identify the source of cosmic rays for the first time. They are jets erupting from supermassive black holes. The key to the solution lay in comparing the new event with an old, nameless signal from the archive. Signals can also be deceptive. In 2014, the discovery of gravitational waves from the inflationary epoch of the early universe, registered by the BICEP-2 telescope, was announced. This would have been a Nobel Prize. But when other teams analyzed archival data from the Planck satellite, which had mapped interstellar dust, it turned out that the signal caught by BICEP-2 was most likely caused not by gravitational waves, but by dust in our own galaxy. The greatest discovery turned out to be an artifact. This case showed how important archival data from other missions are for checking and confirming new results, and how easy it is to mistake wishful thinking for reality. Reality sometimes exceeds expectations. In 1979, Linda Morabito, a JPL engineer, was analyzing Voyager 1's navigation images to refine its trajectory. In one of the images of Jupiter's moon Io, she noticed a strange protrusion on the edge of the disk. Thinking it was another moon behind Io, she enlarged the image. It turned out to be a giant volcanic plume rising 300 kilometers above the surface. This was the first ever discovery of an active volcano outside of Earth, and it was made by chance, by an engineer who was simply performing routine work processing archival navigation frames. Footage from the archives of the Clementine mission, which mapped the moon in the 90s, contained another secret. The spacecraft used a bistatic radar. It sent a signal that reflected off the moon's surface and was received on Earth. In the data reflected from the shadowed craters at the poles, an effect characteristic of water ice was detected. This was the first serious indication that reserves of frozen water could be hidden in the eternal shadow at the lunar poles. The hypothesis was controversial, but it prompted subsequent missions to specifically search for ice there, and it was found. The first echo of lunar water was heard in data that had long been considered too noisy for analysis. Analysis of old data on Mercury, obtained by the Mariner 10 spacecraft in the 70s, revealed that the planet had a weak but definite magnetic field. This was a complete surprise. It was believed that Mercury's small, slowly rotating core should have long since cooled and solidified. The existence of a magnetic field, confirmed 30 years later by the Messenger spacecraft, meant that the planet's core is still partially liquid. The old, sparse data from Mariner 10, obtained during 3 short flybys, held the key to a fundamental property of the planet that went against all theories of the time. Theories also had to be revised after analyzing data on Saturn's rings. In the Cassini archives, images were found of strange, elongated structures in the F ring that appeared and disappeared. They were named jets. It turned out that these were not jets of gas, but traces from the collision of small, loose objects a few meters in size with the main mass of the ring. These mini-comets are likely fragments left over from the collision of larger bodies. The archival images from Cassini allowed us to see the rings not as a static structure, but as a living, dynamic environment where micro-catastrophes constantly occur, shaping its appearance. The appearance of Earth from space also holds secrets. In the archives of photographs taken from the space shuttles and the ISS, images were found of giant red flashes above thunderclouds, named sprites. Pilots had seen them too, but for a long time they were considered hallucinations. Archival space images proved their reality. These are cold plasma discharges that strike from the tops of clouds into the ionosphere at an altitude of up to 90 kilometers. They last only a few milliseconds. These ghostly discharges, tens of times larger than ordinary lightning, turned out to be the missing link in the global electrical circuit of the Earth, and they were discovered thanks to random shots taken by astronauts. Random shots from Hubble, aimed at the galaxy cluster Abell 2218, captured an amazing phenomenon: gravitational lensing. The mass of the cluster warps space-time, acting as a giant lens that distorts and magnifies the images of more distant galaxies located behind it. In the archive of this image, astronomers found dozens of elongated, arc-shaped images of the same background galaxy. By analyzing these distorting mirrors, one can not only study distant objects, but also weigh the cluster itself, including its dark matter. The first textbook on gravitational optics was written by Nature in this archival image. A snapshot can also be auditory. The Huygens probe, which landed on Titan, was equipped with a microphone. The recording of its descent and landing is stored in the archives of the ESA. On it, one can hear the howl of the wind in Titan's atmosphere, then a dull thud on the surface, which scientists described as the sound of landing on crème brûlée, a hard crust and a soft base. This is the first and, to date, the only recording of sound from the surface of another world in our solar system. This short audio file, lost among terabytes of scientific data, allows us for a moment to hear what a landing on a distant cold world sounds like. Cold worlds can also be green. In 2007, while analyzing archival data from Hubble, astronomers discovered methanol in the disk around a young star. This was not a surprise. But when they looked at data from the ALMA radio interferometer for the same object, they were able to map the distribution of methanol. It turned out that it is concentrated in a specific ring, where the snow line lies, the boundary beyond which volatile substances can condense into ice. This was the first direct observation of the snow line of an organic substance, a key zone for the formation of gas giants and the delivery of organics to the inner planets. A map of the future was drawn in the archival radio data. Data can also be historical. In old Korean, Chinese, and Japanese chronicles stored in archives, there are records of a guest star that appeared in the year 1054. It was so bright that it was visible during the day for 23 days. For a long time, this was just a historical curiosity. But in the 20th century, astronomers, after measuring the expansion speed of the Crab Nebula, a supernova remnant, and calculating its age, realized that the explosion occurred right in the middle of the 11th century. The old manuscripts turned out to be the only evidence of the birth of one of the most famous objects in the sky, linking human history with a cosmic cataclysm. The impact of Comet Shoemaker-Levy 9 on Jupiter in 1994 could also have been a cataclysm. But in the archives of Hubble, which observed this event, another story is hidden. After the fragment's impact, dark spots remained in Jupiter's atmosphere. Analysis of their evolution in images taken in the following months allowed astronomers to directly measure for the first time the speed and direction of winds in Jupiter's stratosphere. A cosmic catastrophe recorded in the archive became a unique experiment in celestial mechanics, where the comet fragments acted as a dye, making invisible currents visible. There are invisible currents in our galaxy as well. Analyzing data from the RAVE, Radial Velocity Experiment project, scientists discovered that stars above and below the plane of the Milky Way do not move chaotically. They oscillate up and down, as if someone struck the galactic disk, causing ripples. Modeling showed that such an effect could have been caused by the passage of the Sagittarius dwarf galaxy, the very one we are currently absorbing, through the disk about 500 million years ago. The archive of stellar velocity data turned out to be a seismogram that recorded the echo of an ancient galactic collision. Collisions can also be microscopic. Hubble's solar panels, returned to Earth after a servicing mission, were riddled with thousands of microcraters from collisions with space debris particles and micrometeoroids. Studying them under a microscope, with the archive stored at ESA, made it possible to create the most accurate map at the time of microparticle distribution in near-Earth orbit. Each crater is a record of a collision, and together they tell the story of an invisible but constantly growing threat to spacecraft. The telescope's panels themselves became a detector and an archive of the environment in which it operated. The environment can also be interplanetary. In the data archives of the stereo-heliospheric spacecraft, images were discovered of a comet that completely vaporized while passing too close to the sun. But the most interesting part is that a few hours before this, a small fragment broke off from it, survived the close approach, and flew on. This was the first direct observation of the fragmentation and destruction process of a comet in the sun's corona. These frames, captured by cameras designed to observe the solar wind, accidentally documented the death of one world and the miraculous survival of its fragment. Fragments of the past are also stored in asteroids. The Hayabusa spacecraft delivered microscopic particles from the asteroid Itokawa to Earth. Their analysis, the results of which are stored in scientific archives, showed that the minerals in these particles were once heated to 800 degrees Celsius. But Itokawa is a tiny asteroid. It could never have heated up that much. This means that Itokawa is not a monolithic object, but a rubble pile, the fragments of a larger parent body that was destroyed by a collision billions of years ago. The dust particles brought back from the asteroid turned out to be archival documents telling of its turbulent and hot youth. The youth of the universe was even hotter. In the very first data from the COBE satellite, the predecessor of WMAP and Planck, tiny fluctuations in the temperature of the cosmic microwave background radiation were discovered, 100,000th of a degree. At first, the team feared it was instrumental noise. Months of checking archival data and calibrations confirmed the fluctuations were real. These were the first seeds, gravitational inhomogeneities in the early universe, from which galaxies and galaxy clusters later grew. In this barely perceptible noise, extracted from the archive with great difficulty, we saw for the first time the blueprint for the structure of our entire world. The blueprint for planetary systems also turned out to be not so simple. In the Kepler archives, many systems were found where planets are located very compactly, close to the star. But a detailed statistical analysis revealed a deficit of planets with an orbital period of about 10 days. This doesn't mean they are not there. They probably exist, but their orbits are slightly inclined relative to us, and therefore we do not see their transits. This suggests that even in seemingly flat systems, there is a three-dimensional structure, a result of past gravitational interactions. The absence of a signal in the archive turned out to be just as important data as its presence. The presence of strange signals in Earth's atmosphere also found its explanation in the archives. Elves are giant, expanding rings of light in the ionosphere above thunderstorms, hundreds of kilometers in size. They were predicted theoretically, but were first captured on video from a space shuttle. Analysis of archival data showed that they occur when an electromagnetic pulse from a powerful lightning discharge excites nitrogen molecules in the ionosphere. These fleeting giant structures, lasting for thousandths of a second, turned out to be another way the Earth discharges electrical tension, and their existence was confirmed thanks to accidental video recordings from space. Space, as it turned out, is full of a web. In data from the XMM Newton X-ray telescope, astronomers studying the spectrum of a distant quasar discovered absorption lines corresponding to hot gas. This gas belonged neither to our galaxy nor to the quasar. It was located between them. By comparing this with archival data on the distribution of galaxies, scientists realized they had stumbled upon a filament of the cosmic web, a gigantic structure of gas connecting clusters of galaxies. Most of the ordinary matter in the universe is hidden in this rarefied, hot form, and we saw it directly for the first time, as a shadow against the light of a distant quasar. Light can also be polarized. In 2002, while analyzing archival data on the cosmic microwave background collected by the DAISY experiment in Antarctica, scientists detected its polarization for the first time. This was an extremely faint but important property. It proved that the fluctuations we see truly originated in the early universe and were not created later. This discovery, made based on data from a ground-based experiment, confirmed the fundamental principles of the cosmological model and opened a new window for studying the very first moments after the Big Bang. The quiet hum of the universe's birth turned out to be slightly polarized as well. The polarization of light from exoplanets is an even more complex task. But in 2008, using archival Hubble images taken with different polarization filters, scientists were able to isolate the polarized light reflected from the atmosphere of the planet HD 199733b. This allowed them to determine that its atmosphere contains clouds of tiny silicate dust particles, essentially glass sand. And the color of this planet is a deep blue, like Earth's, but not because of oceans, but due to the scattering of light by these glass particles. We learned the color of a distant world by analyzing not its brightness, but the polarization of its light, hidden in the Hubble archives. Archives store not only light, but also its absence. When astronomers analyzed data from the 2-mass infrared survey, they discovered that in some directions, there were almost no stars. These were not voids, but dark molecular clouds so dense that they completely blocked the light of the stars behind them. One such cloud, Barnard 68, appears in images as an almost perfect black hole in a star field. The study of these ink blots in archival sky surveys has made it possible to understand where and how new stars are born, in the darkest and coldest depths of our galaxy. The depths of space are sometimes reflected in the depths of the Earth. In the data archives on the concentration of the beryllium-10 isotope in ice cores from Greenland and Antarctica, sharp peaks were discovered corresponding to the years 774 and 993 AD. Beryllium-10 is formed when cosmic rays bombard the atmosphere. Such spikes could only have been caused by an extremely powerful solar flare, dozens of times stronger than any observed in the modern era. Old ice archives told us about the fury of our sun, of which we were unaware, showing what cataclysms it is capable of. The potential for discovery is sometimes hidden in re-examination. The planet 51 Pegasi b, the first exoplanet around a sun-like star, was discovered in 1995. But afterward, astronomers returned to archival data from another observatory, collected 12 years prior. And in these old, noisy spectra, they found faint oscillations of the star, corresponding to the very same planet. The discovery that changed astronomy had already been recorded and was lying in an archive, but it went unnoticed because no one expected to find a giant planet so close to its star. Stars may not be alone. In the Hubble archives, images were found of a system with 4 images of the same quasar, lensed by a galaxy. But when the Chandra X-ray Observatory looked at this system in X-rays, it saw 7 images. It turned out that the X-rays are emitted from a much smaller region near the black hole, and therefore they are lensed not only by the entire galaxy, but also by individual stars within it. This phenomenon, microlensing, made it possible to study the structure of the quasar's accretion disk. Archival data in different wavelength ranges gave us the opportunity to use the stars of another galaxy as a microscope. The Earth itself can also serve as a microscope. When an asteroid or a distant star passes in front of an even more distant star, a phenomenon called an occultation occurs. By analyzing archival records of thousands of such events, collected by amateur astronomers around the world, scientists have been able to determine the sizes and shapes of asteroids with incredible precision, find moons and even rings around them, as with the asteroid Chariklo. This vast array of data, collected by enthusiasts and stored in public archives, has become a powerful tool for studying the small bodies of the solar system. Small bodies can also be very distant. Sedna, one of the most distant known objects in the solar system, was discovered in 2003, but its orbit is so elongated that a full revolution takes 11,000 years. To refine its trajectory, astronomers turned to the archives, and they found it on old photographic plates from the Palomar Observatory, taken back in 1990. These few archival points, separated by a decade, allowed for a much more accurate calculation of its path and the understanding that its orbit was likely distorted by the passage of another star near the solar system in the distant past. The past sometimes leaves scars. The surface of Saturn's moon Mimas is dominated by the giant crater Herschel, making it resemble the Death Star. But in the Cassini archives, thermal maps of the moon were found, and they showed a completely unexpected picture, resembling a character from the old video game Pac-Man. The region with a higher temperature is shaped like this character, and it is in no way related to the crater. The reason for this strange thermal pattern is still unknown. Archival thermal images have revealed a new mystery on one of the seemingly most studied moons. Mysteries can also be hidden in the void. Analyzing archival data on the distribution of galaxies, scientists discovered a gigantic structure named the Sloan Great Wall. It is a filament of galaxies 1.4 billion light-years long, one of the largest known structures in the universe. It was not found as a bright object, but as a statistically significant overdensity in a three-dimensional map of the cosmos, constructed from data from the Sloan Digital Sky Survey. This cosmic wall, invisible to the eye, revealed itself only through careful analysis of a giant data archive. Data can tell us not only about what is, but also about what was. Studying archival spectra of the white dwarf GD 362, astronomers discovered heavy elements in its atmosphere: calcium, magnesium, iron. These elements should have long since sunk into the star's dense atmosphere. Their presence means they arrived there recently. Most likely, the white dwarf tore to shreds and consumed an asteroid or a planet from its own deceased system. The atmosphere of the dead star became the final archive, preserving the chemical composition of a world that no longer exists. Worlds that no longer exist sometimes leave dust behind. In the archives of the Spitzer Infrared Telescope, data was found on a star around which a massive dust disk was observed. But this was not a young star, but an old one, where planets should have already formed. Follow-up observations showed that the amount of dust had sharply increased in a short period. Most likely, the telescope accidentally caught the aftermath of a collision between two moon-sized planets. In the archival data, we saw not creation, but destruction, a cosmic catastrophe that generated a cloud of dust, which is slowly dissipating into the void. The void between galaxies turned out not to be so empty. In the Hubble archives, in data from the Cosmic Origins Spectrograph project, scientists were searching for traces of intergalactic gas. They discovered that around galaxies similar to the Milky Way, there exist giant, invisible halos of warm gas, extending for hundreds of thousands of light-years. These halos contain as much mass as all the stars in the galaxy itself. This missing matter, predicted by theories, was finally found. It was hiding in the form of faint absorption lines in the spectra of distant quasars, recorded and stored in the archive. The cosmos itself can also be an archive. Gravitational microlensing is a phenomenon where a star passes in front of another, and its gravity momentarily amplifies the light of the background star. By analyzing archival data from long-term sky surveys, such as OGLE, scientists found events where the light curve was too complex for a single star. It turned out that these were free-floating planets, orphans, ejected from their systems and wandering alone through the galaxy. They are impossible to see directly. The only way to find them is to notice their fleeting gravitational shadow, which they cast as they pass by a distant star, and these shadows are quietly stored in the observation archives. Observations of the Sun also brought a surprise. In the data archives of the SOHO spacecraft, thousands of tiny comets were discovered that flew close to the Sun and evaporated. These are the so-called Kreutz sun-grazing comets. It turned out that SOHO, designed to study the Sun, became the most successful comet hunter in history. Most of these discoveries were made by amateur astronomers who reviewed publicly available SOHO archival images on the internet. Thus, an instrument for solar physics gave birth to an entire citizen science project for searching for icy wanderers. Wanderers can also be interstellar. Oumuamua, the first detected interstellar object, swept through the solar system in 2017. But after its discovery, astronomers rushed to the archives. And in the data from the Hawaiian Pan-STARRS telescope, they found it in images taken even before its official discovery. These few additional points in the archive made it possible to more accurately calculate its strange, non-gravitational trajectory, which is still a subject of debate. The story of the first visitor from another star system began not with a discovery, but with a retrospective look into a dusty corner of a digital archive. Check. We have followed the trails of forgotten signals and seen that space is not only grandeur, but also a whisper. That in every speck of archival dust, in every faded photographic plate, and in every noisy signal, a universe of its own is hidden, waiting only for an attentive gaze. Great discoveries are not always born in a flash of insight. Sometimes they slowly sprout from the silence, from decades of patient data accumulation, from barely perceptible anomalies that someone once dismissed as an error. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy, and let the quiet archives of star charts lull your thoughts. Good night.